Hello, and welcome to our bonus discussion, our Wednesday conversation in this case, I'm going to be talking about online environments. So the basic idea here is that sometimes you want to do analytics in a online environment so that you don't have the challenges associated with hardware running locally and all that good stuff, right? So this isn't necessarily a replacement for getting an environment set up, but sometimes you want to be able to kind of take it with you, so to speak. So I recorded a video yesterday around the concepts of various analytic environments, including Colab by Google, and that's what this is, Google Colab. And that's what I'll be showing you today is how to, in this case, I'm going to take one of the notebooks from one of the deliverables that have already been completed, upload it so you can take a look at it and see what the process looks like and kind of walk through some of the challenges that goes with this experience. So again, I recorded a video yesterday. I shared it as an announcement. You might want to take a look at it, maybe even before looking at this. But Google Colab, as I talked about yesterday, is basically a hosted version of a notebook, very similar to Jupyter, but in the cloud, and kind of pretty nice to deal with. You have the ability to basically either create them, start with some examples, or read them off of various locations, your Drive or GitHub. In this case, I'm going to upload an example notebook from one of the deliverables for this course. So we'll go ahead and do deliverable 1. And this is always a little scary, not because of the technology, because I'm doing a live demo. All kinds of ways this can go sideways. So what I did here was basically, previously I'd put in some markdown that has this marked up with the various types of codes, the various instructions that go with the assignment in a nice little way. And so you have the choice here to go in just to show you kind of what some of this is like. This shows you in a side-by-side sort of way of how the changes you make impact the way it looks right away. So if I drop that down to heading level 2s, essentially second level headings, which is probably what it should have been all along, you can see that it takes place immediately. And then as soon as you're done, you can basically do the typical shift enter to get out of it, and those changes you made are realized in the markdown. And also a nice thing here is it does give you the abilities to do a certain amount of things here kind of in line. So in this case, if we want to bold for some reason, this nearest neighbors, maybe that is what we want to bold, I can just highlight it and do bold, and it does the markdown for me, which is really very nice. So you get the various types of nice little embeddings, so to speak, that are available, easy to use, makes it a lot easier than a lot of the writing that markdown yourself and knowing how to do that by hand. So pretty cool, right? Walking through this, there is one or two things we'll have to make a change. The easiest way to get the data is one of the things I'll show you. The first thing here is you'll notice right now there's nothing up here, but at the point that I run this cell, and you can do so either by clicking on this or you can hit Control Enter, either one works. That basically starts it up and it's running and it's doing some work behind the scenes here. It's actually kind of creating essentially some form of virtualization, most likely some variant of a Docker container is what I would guess, but it's hard to say with certainty. But you can see now we're attached to the Google Cloud backend, so the Google Compute Engine here. And it shows us roughly how much memory is being consumed, how much of the disk is being consumed, and so on. And all that happened at the point that we executed this command. Okay, so if I try to run this, which is what it was locally on my drive, it's obviously not going to work because this data, it doesn't exist inside of here. In the video I did yesterday and did as an announcement, I go through the various ways that you can get around this, and the consensus of most of that was that the easiest way is to use a URL. So I went ahead and uploaded onto a GitHub account that I created for this purpose the deliverable 1 heart data, which is what this is going off of, right? So if we go take a look back here, it's deliverable 1 heart CSV, uploaded that up here as deliverable 1 heart CSV. The way to get the URL that you want to use is to click on this raw link, and it basically shows you that raw file. You copy that over, and I'll go back out, and then replace the file name with that URL, and it's really that simple. And then for simplicity, I'm putting a comment at the end there so that it'll basically comment out the remainder of that line, so it shows me what it used to be. But this is the new URL, and whenever I hit Control Enter, it runs the cell and basically loaded that data frame. And so the next step, I think Control or Shift Enter, either one seems to work. I'm going to take an info of it, so that's basically taking a look at how many entries there are and so on. These cells, the values that are in here right now are from the previous execution. So if I delete that so you can actually see that I'm really running this, so it goes out and it repopulates it for you. That's the nature of notebooks. When we uploaded that notebook, the previous execution's contents were uploaded there. And apologies for the messages that keep popping up. I tried to make it go away, but I needed to have left a conversation that rather than just signing out of Teams. So apologies. So at this point you can see I've did a head. That's the first 10 rows. Nice little UI here with a pretty responsive sort of thing. This isn't quite as nice as Databricks because it has the ability to do things like switch this into various visualizations, but it's really good and better than a lot of what you get in Jupyter natively. The next thing here is I'm going to basically use the Seaborn module to do a plot of the graph, and it's basically just doing a bar graph as to show, what is that, gender, I believe. No, that's the target, and so it shows you the distribution of the different targets. And then a similar thing, gender was next, the pie chart of gender. And a lot of females, I believe, or males, I believe, and then moving into the Matplotlib. And the key thing here to observe is this is the same notebook I ran locally with one minor change, and so it's able to run through. This is without any kind of special sort of stuff. I just uploaded it and I'm running it, and the stuff is just working. So that tells you, kind of speaks to the robustness of the implementation. And so here I'm just kind of running through the rest of this sort of exploration, different sort of graphs, and then we get into the part of actually doing the train test split, which is the normal sort of thing we do, figuring out what the labels are, doing again the train test split off of both the train and the test data sets into the two different things with basically a 25% distribution, some explanation here, converting it to scalar, or creating a scalar converter, and I've included inside of here some comments around that, and this was in the other notebook. I just pulled it in and it's still there and it all works, right? Cool stuff. And I can run it and see the response. And so on. And so you can literally just step through it, taking a look at the results. Then I'm going to go through, create a k-nearest neighbors classifier, and basically giving it what the hyperparameters that we want to start with, and it just works. There's no unusual sort of things I have to do to get this to work. And this is the first time I've ran this notebook in this environment. And I did try out the Deliverable 2 notebook, just seeing, well, okay, will it work too? And it did. So I thought, well, I'll go and take a chance and try to run this one without having ran through it first before. And you can see we've got back an accuracy, and then another accuracy with a different number of K, I believe is the difference here. Yeah, that's what we're doing here, is going through some different values, producing a confusion matrix, and printing out what those cells are. Not in a pretty format, but basically so that you can see what it does show it here. And it's not necessarily that pretty, but you can see the matrix, and then I spell out what each one of them are just for fun. And then here we're going through with different Ks to see what they look like, right? Just to plot it out. Also notice it's pretty clippy, right? So it's not real slow. And then producing a classification report here at the end. And that's pretty much it. So the takeaway here is that with very minimal sort of work, I was able to get this pulled in and ran it. For fun, and this is when it probably really will go off the rails. We'll go to try the same thing in Databricks. And so Databricks Community Edition, free, sign up, pretty much unlimited as far as amount of time you can use it and so on. And it is a little more, because you're not really seeing here an import, right? It doesn't really pop up, but it's here. You have to kind of know where to go poke around though. And so you basically have to go into the users area, and then that's me, and I want to click on import. So not quite as intuitive, right? Google made it really easy. And so I want to browse for a file. In this case, we'll go ahead and, for fun, do deliverable 1 again here. And it pulled it in, so we say import. One of the other things that's a bit different here, I'll go ahead and start this process. You have to have a cluster for Databricks to work, so you have to create one pretty much every time. You can pick optimized clusters that are potentially intended for GPU workloads and so on, although my experience when I try to create a GPU, it's telling me I can't do that. So instead, go with a standard 8.1 of the Databricks runtime. I've got a name associated with my cluster. I can pick where I want it at. I'm gonna go with C because probably most people don't do C. You can do some Spark customizations here, and again, that's the whole point of Databricks, is around letting people learn about Spark in a online, easy to use way. That into serve as essentially kind of a funnel to get you started. So think of it a gateway technology, right? It's to get you started here, and then you want to move on to something else more engaging. So at this point, it's creating a cluster. While it's doing that, I'll go ahead and go back to my notebook that I just pulled in, and that's this deliverable 1. And you can see it comes in very much kind of the same way. So they did a decent job importing it. We can't run yet because we have to attach to the cluster, and the cluster is not up yet. But we can start kind of taking a look at it, and we can even make changes while that cluster is spinning up. The cluster will shut itself down after periods of being idle, but it's not as big of a deal, other than it is somewhat challenging that you have to wait for it to come back up. And it does take a little bit of time, not nearly as fast as it was inside of Google, right? So a different sort of experience. But one of the things here, this will probably be okay, but we're going to have to fix this just like we did over here. So to be a little lazy, I'll go up and just, actually there's no point in that. I'll just copy the raw URL again. And basically it's the same drill. Put that and close it out. And the same sort of thing. So at this point, once the cluster comes up, we should be able to run it. The advantages, and to some extent, that you have with Databricks over something like Google Colab is it is Spark. So if you want to move into more of a big data sort of approach, you want to start playing with koalas, an alternative to pandas that is Spark compatible, so to speak, so that you can actually kind of transition over, and you think of it as doing the same sort of stuff, but you're doing so in a potentially a way that could be distributed later on to multiple nodes. So it's still working on spinning up my cluster. And so it just came up. So now we can go over here. At the point that it turns into the green dot, then you can attach to it. So you can see the green dot, it's up and running. Now we can start stepping through. Similar experience, you hit Shift Enter to go through. A comment doesn't really do anything, and this is when we hit Shift Enter and it runs this cell for us. It is a little bit less zippy in part because it is meant to be running on a cluster with Spark. We're not exactly doing that. Instead, what we're doing is running inside of, we're running basically Python inside of it. So to take a look at what the data frame looks like, we can do that, which basically prints it out. I'll try display. I'm not sure if this will work because it may not know how to display it. But if it does, it'll show it to us in a nice little table. There we go. And the nice thing here, this is one of the areas where is actually probably an advantage, so +1 to Databricks, because you have the ability here to do things like sort off of these various columns. right? So that's really kind of interesting. You can also do things like throw them into potentially a bar graph, although that's not terribly interesting. So maybe a line. But the problem here, we've got too many columns, right? So you'd have to pick which column you're interested in. And I'm not, yeah, we can. So maybe we want to do age, get rid of the keys and just add age. And you can see, kind of cool, right? Built-in analysis, very easy. So it lets you see kind of things, kind of a, it's not exactly, maybe I should see if it'll do a histogram on just age. Yeah. Use this. There we go. So with relatively minor stuff, you can get a certain amount of almost exploration going on, right? And as always, you can switch back to the tabular view, order things in a certain way. Pretty cool stuff, right? So that's one of the areas I'd give it an advantage, right? So that's pretty cool. Keep going through. We'll go ahead and run it. So info ran gives you a certain amount of time of how long it took. Then we can take a look at the head, and it always tells you who ran what and how long it took to run. Just kind of one of the things Spark does, presenting the plot, and it again worked nicely natively, doing the bar graph, and this way not so much. So something here is a compatibility issue that worked elsewhere, cannot call display on that series. So something up there we'd have to look into if we were going to try to get this to work. And then that seemed to work okay. So what was it, Matplotlib, that worked pretty well. That worked reasonably good. And so on. Again, a bit of a compatibility problem here, something that I'm doing that isn't probably either quite right or it's a bit of a compatibility challenge. But again, most of it, that's not too terribly bad. Again, you see this is part of why I did a bias towards Google Colab. I think it's a little better treatment, a little less effort to migrate to, especially if all you're doing is running Python, right? So if all you're doing is using this as an online environment to learn to write some Python in, and you're not taking advantage of any of the Spark capabilities, then you probably want to go with Google Colab. A similar sort of thing, that seemed to work okay. That worked okay. Do the test train split after we create the scalar. It did do the transform, so it scaled it down for us. Then do the display to see the results. Doesn't like that, so it cannot call display on. That's probably an overridden version of display is the problem. It's probably their version versus something else, so that's why that's not working. Then to move into the k-nearest neighbors approach, that seemed to work, and it did find the best p and the best in neighbors, running the classifier, and the rest of this should be fine. Again, a problem with display. Probably print will work. Yeah, print works, not display, because display is kind of overloaded, intended to handle data frames, Spark data frames. And similar, all of these are, it's relatively just display in most of these. Obviously there are some other compatibility issues, and that's part of why the fact that I could take the notebook, do nothing to it, upload it into, and these are all kind of variations on the same theme. Maybe do this at the very last thing. There we go. So without very much changes at all, be able to basically take a notebook, upload it into one of these environments, and run it, and it works pretty good, especially when you talk about Google Colab. It's like rock solid. So given that, it's something to take a look at. Obviously up to you to use whatever environment is the most familiar. 2 or 3 takeaways here. 1, notebooks are cool, right? That's one of the key things to take away, because you can do things like take a look at this one because I went kind of a little crazy here, right? Stuck one of them. I thought it was this one. An animated GIF into one of them. Wasn't this one apparently. So anyway, you can embed animated GIFs inside of your notebooks. Let me see if I can find it. Maybe that one. Nope, not that one. This is the part where it goes sideways. Here, this one. So a notebook that contains an image in it that's running. Very cool, right? And especially this particular case is to try to show the point of here's how you access data in various notebooks like I did in that presentation. But this is an embedded image. And the cool thing here is, again, it just kind of works, right? You don't have to do much energy or effort to get it to work. The editing process for the text is really easy. So if for some reason I wanted to make something bold or italics, right there, it's just italics, right? So it's really easy to get things up and running with this environment. So no, I don't get paid by Google, but Google Colab, very good, very cool. Do take a look. And with that, I'll wrap this up. If you have any questions about what I've talked about, let me know. That's what I'm here for. Stay safe. Again, if you're struggling at all, let me know. That's why I'm here. I want you to be successful. Ping me, email me, whatever works for you. I'll get back to you as soon as I can. Stay safe, and we'll talk again next week.